Good day, everyone. I'm Sir RG Leeson, your math tutor and guide on this exciting journey through the world of numbers. In this video, we will discuss all about joint variation. Let us define first what is joint variation. Joint variation describes a situation where one variable varies directly as the product of the two or more other variables, and one is held constant. The statement A varies jointly as B and C may be translated as A equals to K times B times C, or K equals to A over B times C, where K is the constant of variation. Here, our quantities here or the variables can be two or more variables in joint variation. You can include there 3, 4, and so on. So let's translate each statement into mathematical sentence. Use K as the constant of variation. So we have here Z varies jointly as X and Y. So we have Z equals to K times X times Y. Number 2, V varies jointly as L, W, and H. So when we use joint variation, so we just need to multiply or to find the product of the given quantities or variables. So we have V equals to K times L times W times H. Example number 3, the area of the parallelogram varies jointly as the base, B, and the altitude H. So we have A equals to K times B times H, or area of the parallelogram equals to K, or constant of variation, times the base and the altitude, or H. The force F applied to an object varies jointly as the mass M and the acceleration A. So we have here F equals to K times M times A. The volume V of the pyramid varies jointly as the area of the base and the altitude height. So we have here V equals to K times B times H. So let's, what are the steps in solving joint variation? First, we need to write the variation equation. We have A equals to K times B times C, or K equals to A over B times C. Second, we need to substitute the given values to find the value of K, or the constant of variation. Third, we need to rewrite the variation equation as A equals to K times B times C with the known value of K. And lastly, we need to substitute the remaining values and find the unknown. Example number 1. Find the equation of variation and solve for K if Z varies jointly as X and Y, if Z equals to 16 when X is equals to 4, and Y equals to 6. So step number 1, we need to express the statement Z varies jointly as X and Y as Z equals to K times X times Y. And in step number 2, solve for K. We just need to substitute the given there to find the constant of variation. So we have Z equals to K X times Y. So we have Z are 16 and X is 4 and Y is 6. So we have 16 equals to K times 4 times 6. 4 times 6, we have 24. So we have 16 equals to 24K. Divide both sides by 24 so that we can find the value of K. So we have here our K is equals to 16 over 24. We can reduce that one. So we have K is equals to 2/3. That means our constant of variation is 2/3. And our equation of variation now is Z equals to 2/3 times X times Y. Next example, we have Z varies jointly as X and Y, and Z equals to 60 when X is equals to 5 and Y is equals to 6. Now we have here also, so we need to find the missing variable or the value of that given there in the A, B, and C. Now, but first we must find the constant of variation before answering A, B, and C. So express the statement. We have Z varies jointly as X and Y as Z is equals to K times X times Y. Substitute the given. So we have here 60 equals, let's just focus in the here in the statement, z equals to 60 when x is equals to 5 and y is equals to 6. Because our goal first is we just need to find the constant of variation before answering A, B, and C. Okay, so we have 60 equals to k times 5 times 6. 5 times 6, we have 30k. 60 equals to 30k. Divide both sides by 30, we have k is equals to 60 over 30. And we have k is equals to 2. That means our constant of variation now is equals to 2. And then the equation of variation is z equals to 2 times x times y. Now, since we have now the equation of variation, we can now find the missing value of a. We need to find z when x is equals to 7 and y is equals to 6. So, we will use the equation of variation z equals to 2 times x times y. So, substitute the given. So, the z now, z equals to 2 times 7 times 6. We have z is equals to 84. Therefore, z is 84 when x is equals to 7 and y is equals to 6. And next, we need to find x when z is equals to 72 and y is equals to 4. So, we will use again z is equals to 2 times x times y. So, we have 72 is equals to 2 times x times 4. So, 2 times 4, we have 8x. Then, we divide both sides by 8. We have x is equals to 9. Therefore, x is equals to 9 when z is equals to 72 and y is equals to 4. And then, for this item, last letter, we have find y when z is equals to 80 and x is equals to 4. So, we will use z is equals to 2 times x times y. Substitute, we will get now 80 is equals to 2 times 4 times y. 2 times 4 times y, we have 8y. Sorry for that. Let's edit this one. So, we have here 80 equals to 8y. Divide both sides by 8. We will get y is equals to 10. And then, therefore, y is equals to 10 when z is equals to 80 and x is equals to 4. Okay. Next example, we have if y varies jointly as x and square of z and y is equals to 48 when x is equals to 3 and z is equals to 2. Find the constant of variation and b the value of y when x is equals to 2 and z equals to 3. So we need to express first the statement y varies jointly as x and the square of z as y equals to k times x times z squared. So substitute the given. So we will get 48 is equals to k times 3 times 2 squared. And then 2 squared is 4. So 3 times 4, we have 48 is equals to 12k. Divide both sides by 12. We will get k is equals to 4. That means our constant of variation is 4. And then the equation of variation now is y equals to 4 times x z squared. Now, to find now, since we already know what is the constant of variation, we will now find the value of y when x is equals to 2 and z is equals to 3. So, we will use the equation of variation y is equals to 4 x z squared. So, substitute the given. So, we have y is equals to 4 times 2 times 3 squared. We have y equals to 4 times 2 times 9. So, we have y is equals to 72. So, therefore, y is equals to 72 when x is equals to 2 and z equals to 3. So, let's have an example, a word problem example about joint variation. So, the area of the triangle varies jointly as the base and the height. A triangle with a base of 8 cm and a height of 9 cm has an area of 36 square centimeters. Find the area when the base is 10 cm and the height is 7 cm. So first, we will find the constant variation of this given problem. So express the statement, area of the triangle varies jointly as the base And height, so we have here A is equals to K times B times H. And then solve for K, substitute the given, so we have 36 is equals to K times 8 times 9. So we just need to disregard the unit here because since we are finding the constant of variation. So we have 8 times 9, we have 72, so we have 36 is equals to 72K. Divide both sides by 72, you will get K is equals to 1/2. Now, the constant of variation now is 1/2, and the equation of variation is A is equals to 1/2 times base times height. Now, we will now find the area of the base, the area of the triangle when the base is 10 centimeter and height is 17 centimeter. So, we will use the equation A is equals to 1/2 times base times height. So, we will use here, substitute the given, so we have A is equals to 1/2 times the base is 10 and the height is 7. So we have A is equals to 1/2 times 70 centimeters squared. So we will now input the unit here. Sorry, I forgot. So we have 10 centimeter times 7 centimeter. We have 70 centimeters squared. So 1/2 1/2 times 70, so we have 35 centimeters squared. So that means the area of the triangle is 35 centimeters squared. Last example, we have the mass of the rectangular sheet of wood varies jointly as the length and the width. When the length is 20 centimeter and the width is 10 centimeter, the mass is 200 grams. Find the mass when the length is 15 centimeter and the width is 10 centimeter. So first, we need to express the statement mass of a rectangular sheet of the wood varies jointly as the length of and the width. So we have here M is equals to K times L times W. So we need to solve for K, or the constant of variation. Substitute the first set of the given. So we have 200 equals to K times 20 times 10. So 20 times 10, we have 200 K. So 200 equals to 200K. Divide both sides by 200. So we will get K is equals to 1. That means the constant of variation is 1. And the equation of variation now is M equals to 1 times length times width. Now, we will now find the mass when the length is 15 centimeter and the width is 10 centimeter. We will use the equation of variation M is equals to 1 times L times W. So we have here 1 times 15 times 10. We have the mass is 150. Therefore, the mass of the rectangular sheet is 150 grams. Thank you so much for watching. I hope that you've learned something today and you will apply this one in your life experience. And also, please don't forget to like and subscribe and share it with your friends, to your grade 9 student friends. God bless everyone. Goodbye.